Welcome back to the channel. This is an extension of the video I did fitting the Fluke 1587 FC into the Veto MB2 at the back there. So I was going to use this as my transducer test setup, and this is the test setup that I end up with in front of you here. The Fluke instrument is sitting there at the front alongside the current transducer. This one is 0 to 1 amp input, which is coming from the Megger SMRT1 over there at the back, and the output is wired here at the back into the Fluke set up on current measurement, and is actually transmitting to the iPad here. And one annoying thing about this is that the iPad will not record landscape, so we have to tip it up onto its side like that. The other connection I've got into transducer is 110 volt AC, which is coming from a power supply outside of the picture. That would normally come from the panel that I'm working in. At the back I've got the laptop running, and that provides the control to the Megger SMRT1 there. I've got a ramp set up on this that is 0 to 1 amps AC, 50 Hertz, and I've got 4 steps on it at 250 milliamp steps. So you see at the moment the transducer is just energized. It's kicking out 4 milliamps with no input onto it whatsoever. So we will press record on the laptop and we set the SMRT1 running, and I should be recording the results. So there it goes up to its first step, 8 milliamp output. Second step, 12 milliamp output. Third step should be 16 milliamp output. It's getting a little bit high. There's 1 amp going in and 20.10 going out. And that's the end of the test. You can see on the end screen of the computer there, relay did not operate alarm. Unfortunately, the SMRT is configured more for protection relay testing and not really transducer testing, or if it is for transducer testing, I haven't figured it out yet. And I can't get rid of that error message. It doesn't mean anything because I'm just recording this as the input really, so I can just accept that and get rid of that. And there you see I can have the result displayed upon the screen, and what I'll be able to do now is export this out either as a PDF report, or what I will do is put it into Excel so that I can do some more analysis on the readings, which I'll show on the computer now. Okay, so this is the data pulled into the computer, sitting here in Excel. This is how it comes in under its default format here. You can see as it was a CSV file, so it's pulled in the date and time of the reading and then the actual value that it recorded. The first element that I have to do is to remove where the meter had a step change. So if I go down to here, you can see coming down at 4 milliamps here. You can see it starts to change to 4.12, 6.92, 7.96, and then on to 8. So I will remove these 3 lines here before I do any analysis, because they would interfere with the actual tolerance readings that you end up calculating. The Fluke is also recording around about 4 readings per second, so it isn't fast enough to measure the response time of the transducer. To do that I'd have to use an oscilloscope or something like that. So that's the first little issue that I have with regard to this. Once I've removed all these slightly erroneous readings here, I can then move on to formatting the data and calculating the tolerance, the maximum, and then I calculate the data for a histogram, and that enables me to look at the other data that's available to produce some plots. First is the box plot, and you can see here this is the bulk of the readings with regard to the tolerance in there, but you can also see up here there's a 1%, there's a reading at 1%, which starts to look like an outlier to me. I can look at that a little bit better. If I look at the histogram over here, again you see it, the bulk of the readings are down here at this 0% tolerance to 0.5%, and you've got this reading up here on its own, sitting well and truly away from the bulk of the readings. If I plot all those tolerances, you can see here, where are we? Yeah, here we are, this reading here. This is the 1% reading, so you see it's somewhere around about reading number 30 in there. So what I would actually do is remove any reading that looks erroneous like that. Could occur for any number of reasons really, but it doesn't fit in with the rest of the data. So that would get taken out as well, and from that I then end up with a complete table where I've calculated the differential values, and I can then move on to average data, which eventually it leads me on to calibration sheet. And I would actually PDF this up and give this to the client. Took it there you go. So this shows what I've actually done, the date, where the transducer came from, the panel it was from, serial number, the type, and its rating. That's its class, it's 0.2% class, and this is where I get the minimum and maximum values from. So for a transducer, the class is 0.2% of the maximum output, which is 20 milliamps. So I have a 40 microamp tolerance on any of the readings that I take. And you can see here, this is the as found. You saw when I tested it earlier in the video that it was actually out, 20.09. Max I can have is 20.04. Again, 16 milliamp was out as well. So the span needed a little bit of adjustment. Once I've adjusted it, I can bring it back down into, and these are my as left readings, and I give them an overall result that the unit has been left in tolerance, and there's my little output plot there, and I do that for each transducer that I tested. So that leads on to another issue that I just need to make you aware of with this setup I've got, and that is the actual tolerances that I'm working to. You can actually see, as I said here, the class is 0.2%. For this particular transducer, for a Sinex transducer, it's actually 0.5. The Fluke has a tolerance of 0.2% on the current milliamp scale that I'm using to take these measurements. So for this transducer, you can just about get away with it. Ideally, you want a minimum of 3 times better tolerance for the instruments that you're using to take the measurements. So that would be reasonably close for the Sinex transducer. For the ISAT transducer there, it's not. It actually equals the class. So technically I can't really be using this setup to take these measurements, but there are a couple of caveats that enable me to actually make these measurements. So the first reason why I can get away with having such a low accuracy on the Fluke is that the transducers that I'm measuring are purely for indication into the control system. I'm not doing any fiscal metering or any weights and measurements systems. It's purely for trending of the current in motors and distribution boards and systems like that. So absolute accuracy is not paramount for that application. The second reason that I can get away with this is I have some very accurate metering here. The Keithley 2450 source meter. I keep that independently UCAS calibrated. It costs me an absolute fortune because it has to go to Germany for that calibration. And I can check any instrument I've got against that meter at any time I feel like, and verify that the meters are reading okay. And what I have here is the 1587. I'm kicking out 8 milliamps on the SMU, and you can see I'm reading exactly 8 milliamps on the 1587 there. The Keysight U1461A here, that is also 0.2% accuracy and also has 10 microamp resolution, exactly the same as the 1587 FC. So I don't gain anything by moving to this instrument in comparison with what I can do with the 1587 FC there. But as you can see, that also reads 8 milliamps as well. If I want to improve the accuracy, then I have to have something like the Keysight U12828A here. That is 0.05% accuracy. So that can do fairly legitimate readings, certainly on a 0.5% class transducer, but also on a 0.2% class transducer on 4 times better resolution. So I've just crept past my 3 times preference for measuring accuracy. However, you can see that this is reading 8.009 milliamps, so this gives me 1 microamp resolution, so it's better than those two instruments. But in comparison to my Keithley, which is in actual fact 0.025% accuracy on this, and it's reading 8 milliamps dead down to 100 nanoamps there. So this instrument is slightly out in comparison to that. So that's how I can get away with doing these kind of measurements with the instrumentation I've got there. I just wanted to make sure you were aware of that and the reasoning behind it. Okay, so that's my test setup there for field testing transducers. I'm using the Megger SMRT1 and Fluke 1587 FC there that I keep housed within the Veto MB2 meter bag. There is only one element that I would probably change with the physical setup that I have here. These adapters that I put in the side pocket here. Out of the way. The four here that I've made up myself, they're all okay. It's actually the purchase ones that I got from, I think it's a Staubli I got them from. They're quite a bit shorter. And then the other ones, as a consequence, they disappear inside, right inside the side pocket there, and I lose them a little bit. So I guess what I'll do is I'll get some more 4mm connectors there and make up another set of leads myself, and then they won't hide inside the side pocket there. It's not a big issue, it's just a little inconvenience that annoys me every now and again. So other than that, yeah, as I say, I'm pretty happy with the test setup that I've got here. For me, the way I could really improve this setup is if Megger came out, adapted one of these units specifically for transducer measurement. So they've got the current capability. Actually, in this 1 voltage module that they have here, that it also has current capability up to 15 amps, which is fine for transducer testing for me. So just a unit with one of those modules in there, and then instead of having binary inputs, if they had an analog input to a specific program to do the ramp and measure 4 to 20 milliamps or 0 to 10 volts, whatever you require, that would be the way I would get a good improvement over using this setup that I've got. But currently, at this moment in time, other than going to the huge Omicron, which is a pain to carry around, this is the best setup that I've got at this moment in time for testing transducers out in the field. So okay, that's it for this video. Thanks for watching. Hope you found it useful, and I'll see you in the next one.